Welcome back, trio. Here we are. Today we're going to go over derivatives. Find the derivative of the square root of x. So we can rewrite this so we can use the chain rule. If we rewrite this as d dx of square root of x, that's the same as d dx of x to the 1/2. So now, when we do the derivative of this using the power rule, we just take that power, move it over, multiply it to the coefficient, and then reduce the power by a factor of 1. So, we get 1/2 x to the 1/2 minus 1, or 1/2 x to the negative 1/2. Well, that negative tells us to move it. I always say when I see a negative in the exponent position, I like to move it. So we got to move it. We got to move that base. So that means we get 1/2 times 1 over x to the 1/2. Or 1/2 times 1 over square root of x. Multiplying those together, we get 1 over 2 square root x. And that's our final answer. Now I'll be back with another problem. Welcome back. Here we are with another example. Find the derivative of x to the pi power plus 6. 6 being the constant term. And again, all we have to do is remember the power rule. So let's write it out. d dx of x to the pi plus 6. We can look at that as d dx of x to the pi plus d dx of 6. So when we're doing the derivative, we have to do the derivative of each and every term. So here, this is just that power rule. So we get pi times x, take that power, multiply it to the leading coefficient, and then reduce the power by 1. So that's pi minus 1 up here in the exponent position. Plus, the derivative of a constant term is 0. So anything plus 0 is itself pi x to the pi minus 1. That's our final answer. I'll be back with another example. Welcome back, trio. Here we are with another example, finding the derivative. With this problem, we actually have to use the power rule in conjunction with the chain rule, because we have an outside and an inside. So whenever you have a composite function, this could be broken down into two different functions, then we use the chain rule to find the derivative. So let's look at that. So we're taking the derivative of the whole thing, which means we have to take the derivative of the outside. So that's bring down the 5, reduce the 5 by 1, that gives us a 4. Rewrite the whole inside. Then times that by the derivative of the inside. So now, taking the derivative of the inside using the power rule, we take the derivative of 2x, that's 1 times 2 is 2. The x goes away. Derivative of the constant is just 0. So we get 5 times 2x plus 3 to the 4th. 2 plus 0 is just 2. Take that 2, multiply to this 5. 10 times 2x plus 3 raised to the 4th power is the answer. this is the final answer. I'll be back with one more example. Welcome back. Here we are with our last example for this video. Derivatives. Find the derivative of e raised to the power negative x squared. So again, this is going to be the power rule and the chain rule and a special derivative rule for e. So now we're using 3 rules. So let's get it done. Derivative with respect to x of e raised to the negative x squared. So with the power rule, with the chain rule, we have to take the derivative of the outside function and then take the derivative of the inside function. Well, e raised to a power, we're going to do that and then take the derivative of that power. So that's going to be the chain rule. Now, the derivative of e to the x is e to the x. So the derivative of the outside part is e to the negative x squared. But we still need to multiply that by the derivative of the inside function here, negative x squared, which means we need to use the power rule. So take that power, multiply it here, that becomes negative 2x, reduce it by 1, so that's just negative 2x. Negative 2x. Multiplying everything together, we get negative 2e, negative 2x, e to the negative x squared. Taking this, moving it to the front. And we're done. Okay, thank you for watching this video. Go Trio!